You've read this sentence before. Not this video, not this channel, this exact sentence. Somewhere, right now, someone with your face, your voice, your fingerprints is sitting exactly where you're sitting, reading these exact words, at exactly this moment. And it's not a metaphor. It's not deja vu. It's not spiritual. It's physics. And some of the most serious cosmologists alive take it seriously. Here's why. Let's start small. You, one body, about 7 octillion atoms, arranged in one very specific way, the way that makes you, you. Now zoom out. Your room, your city, Earth, a rock floating in the dark, 8 light minutes from a star. Zoom out further, our solar system, a speck inside the Milky Way. 200 billion stars, and we're not even near the middle. Keep going. The Milky Way is one of over 100 billion galaxies we can see. And see is the key word. Because what we can see has a wall. That wall is called the observable universe. It's about 93 billion light years across. Not because the universe stops there, but because light from anything farther hasn't had time to reach us yet. The universe is 13.8 billion years old. Some of it is simply too far for its light to have arrived. So here's the question that breaks everything open. What's on the other side of that wall? Most cosmologists will tell you the same unsettling thing. Probably. More universe. In 2020, a team of researchers reanalyzed data from the Planck satellite, humanity's most precise map of the early universe. They were checking one specific thing, the shape of space itself. Is it curved, like the surface of a ball, which would make it finite, closing back on itself? Or is it flat, stretching out, potentially forever? The answer came back flat. Not probably flat. Flat to a precision of about 4 parts in 10,000. Meaning if the universe curves at all, the curve is so slight that our best instruments can barely tell it apart from dead flat. That result has held up since, even as a few papers have pushed back and argued for a slight curve. Flat geometry is consistent with something most people never really sit with. Space that never ends. Not big. Not bigger than we thought. Now hold that thought, infinite space, and introduce a second fact, one that sounds unrelated until it isn't. Take any region of space. Say a cube the size of Earth. Fill it with a fixed number of particles. How many different ways can you arrange those particles inside that cube? The number is monstrous. Beyond monstrous. But it is not infinite. There's a hard ceiling. A finite number of possible configurations. Every atom, every quantum state, every possible position, it all runs out eventually. This is the same logic as a coin. Flip it once, 2 outcomes. Flip it 1,000 times, the number of possible sequences is almost incomprehensible. But it's still a number. It still has an edge. So now put the two facts in the same room. Fact 1, space might go on forever. Fact 2, the number of ways to arrange matter in any region does not. Flip a coin infinite times, and every possible sequence doesn't just happen once. It has to repeat. Infinitely. Not because it's spooky. Because it's math. Given infinite tries, and a finite set of outcomes, repetition isn't likely. It's guaranteed. In a region of space exactly the size of Earth, with a very specific arrangement of atoms sitting in a chair reading a very specific sentence, is just one configuration. One outcome, out of the finite set. Which means if space really is infinite, that outcome doesn't happen once. This isn't science fiction. It has a name, and it's not the multiverse you're picturing from the movies. Physicist Max Tegmark calls it the Level I Multiverse, the most conservative version of the idea that other universes exist. No parallel timelines, no branching realities, no alternate choices. Just this, the same laws of physics, the same universe, repeating, because it's simply run out of new ways to arrange itself, and started again. Tegmark first laid this out formally in a 2003 paper, and he's returned to it since. It isn't a fringe theory. It's a direct consequence of two mainstream ideas. That inflation gave us an enormous, possibly endless universe, and that physical information in any given space is finite. Somewhere out there, by this reasoning, is a region exactly the size of everything you can see from Earth. The same stars, the same sky, with someone in it, reading the same words, in the same order, right now. You're going to want a number. Everyone does. So here it is, and it will not comfort you. Tegmark has calculated the distance to the nearest exact copy of you, atom for atom, at roughly 10 to the power of 10 to the power of 29 meters away. Not 10 to the 29. 10 raised to a power that is itself 10 billion billion billion. The observable universe, that whole 93 billion light-year wall we talked about. It would fit inside that distance more times than there are atoms in your body. And if you want the nearest copy of the entire observable universe, every galaxy, every star, arranged exactly like ours, the number climbs past 10 to the 10 to the 115. These aren't numbers you're meant to visualize. Nobody can. They exist only to make one point: it's not close. It will never be close. But in a truly infinite universe, not close and impossible are two very different things. Sit with this for 1 second. If it's out there, that other you, it isn't a soul, or a ghost, or a twin from another dimension. It's made of the same laws of physics, sitting in the same kind of chair, having lived, atom for atom, the same life you have. Not a duplicate in spirit, a duplicate in fact. Right now, in this model, they are hearing the same sentence, in the same tone, and in a moment they will finish it exactly when you do. Then their life keeps going. Exactly like yours will, not similar to yours, not like a parallel choice, the same. That's the part that sits wrong, not the distance, the exactness. But here's where a good story has to stop pretending it's a settled fact. Because this entire argument rests on one unproven if. If space is truly, actually infinite, not just larger than we can see, but endless, then the repetition is mathematically forced. But we don't know that it is. We know space is flat, or extremely close to it. Flat geometry is consistent with infinite space. It does not prove it. The universe could be flat and still finite, just enormous, curling back on itself in a way we haven't detected yet. Right now, that question, is space actually infinite, is one of the genuinely open problems in cosmology. Not solved. Not settled. Argued about in real papers by real physicists as we speak, which means everything in this video is real reasoning. Built on real, mainstream physics, hanging on a single, honest, unanswered question. So no, this isn't a ghost story. It's not saying you're being watched, or haunted, or replaced. It's saying something stranger, and somehow colder. That if the universe never ends, neither does the arrangement that makes you, you. It just starts again, somewhere past every wall we can see. We don't know if that's true. We may never know. But the next time this exact feeling creeps in, the sense that this moment has happened before, you'll know it's not a glitch, it's a possibility. Written into the math of an infinite sky,